Hello, students and teachers. This is regarding task one of AS and A level computer science pre-release material for paper two. This is regarding task one only. First thing we need to discuss, and it is fairly necessary to understand that since many of the students are appearing AS for the very first time after their O levels, what happens in O levels is the scenario for pre-release material that appears in pre-release material before exam is exactly same as it appears in um, the document before. So they O-level students, they prepare around that particular scenario. Questions over there are fairly predictable. So they have an idea that what sort of questions would come because the scenario doesn't get changed in exam. In exam, they see the same scenario. Whereas in AS level, this pre-release material is actually a practice paper. It should be taken as practice paper. Neither the question which are in this PRM appear in exam, nor the exam is limited to the topics appearing in this. So it is clearly mentioned by CAIE by themselves. So let's see. It says that there will be questions on the examination paper which do not relate to this pre-release material. So be aware of it. And you need to prepare for structured English and pseudocode and program code. And this program code must be either of Visual Basic, Python, Pascal, or Delphi, and there must not be any graphical interface design for input and output of data. That should be fairly just the console mode. All right, so let us start. Task one is about structure charts. It says that describe a processing activity that can be represented by one main task with two or more subtasks. The activity can relate to any scenario, but should include aspect of selection and iteration. Activity example may be taken from different areas such as school or college, factory and workplace, clubs and hobbies. Viewers, you need to understand one thing. This is not a project. This is a paper which would have so many questions. So one question cannot be related to just, all of the questions cannot be related to just one topic. So there would be fairly a number of topics, at least 5 to 6, which will be appearing. So this solution should not be done in terms of project. This solution should be done with the aspect of past papers in mind, means short questions for short scenarios, it's small scenarios. So let us start. First of all, let's discuss about structure charts, what they are, how do they actually work, how they help, what are the benefits of these and all. So let's start. First thing is decomposition. Decomposition means breaking problem down into subproblems in order to explain a process more clearly. Decomposition leads to the concept of program modules and using subroutines and procedures in terms of functions and procedures. What does that mean? It means that if you have got a bigger problem to deal with, rather than you uh, deal with it as a single person, you better break it down into number of subproblems and then in turn look into every subproblem so that it can further be broken down. So over here I try to explain it like, let's say there's a program which I have broken down into two modules, and then I visited every module, and if I found it possible that I can further break it down, I have broken it down. And then same happened with module 2, but one of the subroutines under module 2 can further be broken down. So this approach fairly helps programmers and programming teams and IT administrators for the reason that it enables them to distribute a bigger solution into number of programmers. So that brings down the development time of the whole solution, number one. Number two, when the programmers are given their part of the solution, they are given that part as per their expertise. They have expertise in it. When someone has expertise for one thing and they are doing what they love to, it means that there are less chances of errors, and the time that they will take to develop the solution and the quality of the solution will be improved and time will be reduced. And with the passage of time, what would happen that a library of these subroutines will be, or modules will be created that can be reused further in future development, that further reduces the development time. So this is a good idea to break a problem and get it done through number of people so that the development time reduces and the chances of errors are reduced, debugging becomes easier, and a library of subroutines is created. Now, this decomposition may also be defined in terms of stepwise refinement, modular design, top-down approach. These all are the terminologies used for this decomposition. So, now this practice of subdividing each part of the larger problem into a series of smaller parts and so on as required. Now, a structure chart. It is a modeling tool used to decompose a problem into a set of subtasks, means it is decomposition. It shows the hierarchy or structure of the different modules and how they interact with each other. So a structure chart is a form of decomposition. It helps us to show that how these modules which we have actually found out of a bigger problem, they interact with each other, how they pass on the data values among them. So it does not describe logical pathways in them, but just the interaction and levels. So now, a structure chart, let's discuss a structure chart. Structure charts are like top-down approach or decomposition, but they have one more thing added to them, and that is the interface. That when one module, let's say main module calls a submodule, module A, and it passes on some data to it, like A is being passed from main module to module A, and then module A is returning X, and then that X by main module is being transferred to module B. This is called interface. And you need to understand that when a structure chart is made this way, module A will be called first and then module B. There is no other way, if it is not defined, to think that it might be a different way calling these or other way around. It is always from left to the right until unless there is something attached to it. So this is called sequence. When modules are called, they are called in sequence from left to right. This is level 0 modules or subroutines, and these are level 1 subroutines. And when the data is being transferred, it is being transferred with the help of parameters, and these parameters are shown using these shapes, which is data couples. Now, over here, there is sequence, but the thing is that after calling module A, transferring A to it and getting X back, this main module will be calling module B and C again and again and again. So this arrow is actually showing what? Repetition. So it is calling module B with X, B is returning Y, and with that Y, it is calling module C. But this is happening again and again until a condition satisfies. Let's say this is a while loop, and calling of these module B and module C is placed inside that loop. So until that loop works, this module B and C will be repeatedly called. And then it is selection. Selection is the use of if then else. Main module calls module A and then module B, and then module B has an if condition, or maybe select case condition, or case and case condition, where it is being checked, and if it is true, it is being called module 1. Module B1 is being called, and if it is false, then module B2 is being called. So this shape, I hope that you understand or you remember this shape from flowcharts. It is same diamond shape which shows selection. Now, data couples. As I told you that when a subroutine calls another subroutine, they transfer the values, which are called parameters. And these parameters are shown using data couple shapes. So data couple what? Data couples show values transferred between the modules or subroutines that describe parameters. Now, this is the first type of, which is most commonly used. It shows that a parameter is being transferred. This is any data type. But sometimes if a function is called or a procedure is called and they are returning a Boolean value, which is true or false, to show that if something has happened. For example, um, we are searching for some data and we need to know if that data is present or not. We called a function with the value, and function returns true or false. That true false will be returned with the Boolean variable, and that variable is regarded as a flag. So flags are shown with these filled circles, black circles, dark black circles, whereas simple parameters are shown with these empty circles. So this is called flag, shows that the value transferred is a flag, a Boolean variable. Now, sometimes you might see things like this. See, sometimes it is not always necessary to transfer actual variables and to catch them in other variables at subroutine level, sub-subroutine level. Sometimes variables locations are being shared as in pointers, or if we are using Visual Basic, then by ref. So what happens that actual variable is not transferred, its location is transferred, so that if the called subroutine makes changes to it, those changes will become apparent in the caller's variable then and there at once. So this is a pointer to the variable value being transferred, as in variable value is updated within the called module. Now, this was the introduction of a structure chart. So what is the purpose and use of a structure chart? Let's revise again. A structure chart is a modeling tool used in program designed to decompose a problem into a set of subtasks. The structure chart shows the hierarchy or structure of the different modules and how they connect and interact with each other. Each module is represented by a box, and a parameter passed to and from the modules are shown by arrows pointing towards the modules receiving the parameters. Each level of the structure is a refinement of the level above. So that is why we also call it stepwise refinement. So let's start solving few of the questions. I hope that that will make your understanding good of this topic. So let's viewers start with the latest paper. This is paper 22 from June 19. Let's start. This is question 3, which is related to our structure charts. So now this question is about structure charts. Let's start solving it. So it says the following structure chart shows the relationship between three modules. We have got top level module, and then we have subroutine A and subroutine B. Top level module calls subroutine A first and then subroutine B. And when it calls subroutine A, transfers A and B, whereas C is being shared among both. It means that C is, when subroutine A updates C, it gets updated at top level as well. And then top level calls D and E, calls subroutine B with D and E parameters, and B returns a flag. So uh, it says that parameter A to E have the following data types. A and D are string, C is character, B and E is integer. Write the pseudocode header for module subroutine A. As we can see that subroutine A is actually a pseudocode. They have told us that it is a pseudocode. So it receives two parameters A and B, and pseudocodes do not return any value. Function returns a value. So if you mean to share a variable in terms of that it returns something to it, then we have to share it by reference or as a pointer. So write a pseudocode header for module subroutine A. So let's see how. So we be like, it's a pseudocode. So it's a procedure. Mind one thing. In our syllabus, functions do not take input from console. Functions do not share variables in terms of by reference or pointer. Functions only return a value. They accept values as parameters and they return a value. Whereas with the procedures, our syllabus somehow is made that it may or may not accept values, but it takes input from the console. Number one, it may output to the console, and it shares variables in terms of by reference. Means sometimes you would see that a procedure is being called and it is returning a value, but it is taking from outputting to the console and all. So mind it, a procedure can have variable with reference. A procedure can output to the console, whereas function never output to the console. It does not take input directly from the user. It accepts values. A function accepts values and parameters and always returns a value. So if there is any sort of interaction with the user on the screen, it is procedure. All right, so let us start. So this would be like procedure. Procedure sub A, it accepts A. The type of A is string. Then it accepts B. The type of B is integer. And then it is returning and accepting C by ref. By ref C as character. Then we have write the pseudocode header for module sub B. Sub B is accepting D and E and returning a flag. And D is string, E is integer, and flag we know that it's Boolean. So let's solve that as well. And since it is not using any byref or anything and it is returning a flag, it is a function. So subroutine B will be taken as a function. How do we know that this is a procedure? Because it was actually sharing a variable, and I told you that when a variable is being shared with reference or as a pointer, then it is always a procedure. So now this is a function because it is accepting two values and returning a flag. So function sub B, it accepts D as a string and E as integer, and it returns Boolean. Now, module hierarchy and parameters are two features that may be represented on a structure chart. Instead, two other features that can be represented. As I told you that structure charts other than modules and hierarchy and parameters show what? Selection, sequence, and iteration. So that would be selection, iteration, and sequence. This completes this question. Let's have another question. This question is again a latest question from May, June 2019. This is from paper 2-3. This is again question number 3. So it says that following pseudocode represents 3 separate modules from an algorithm design. There's a function search AA, then there's a function allocate, then there is a procedure enable. So, sorry, the first function is search. It accepts A as integer, BB as a string, and returns integer. Then there is another function, allocate. It returns Boolean, accepts nothing. And then there is a procedure, enable. It accepts CC, and by reference DD. Remember two-sided data couple as integer. And then fourth module setup refers to the previous 3 modules as follows. So setup is actually calling allocate and search inside a loop. So this is a procedure calling, this is a function calling, this is a function calling, and the loop is there. So it is between while and end while. So this is a procedure which is called setup, and it is calling rest of the three modules. I mean subroutines. So let us start. So first of all, setup. This is setup procedure. It is calling search. Search is a function. When setup calls search, it transfers A and A and B and B. Then it calls allocate. Allocate is a function as well, and it returns a Boolean value. So it will be filled. And then setup calls enable. Enable, when called, it is called with the CC. It is called with this value which is received in CC. So, and the value which is being returned is actually the value which is being shared as reference. So this will be by ref thing, it will be shown like this. This is your answer for setup. This is 6 marks question. I hope that you would have understood it properly. Now, part B. The algorithm is implemented in a high-level language, changes are required, and the program is given to Albert, who is an experienced programmer. He is not familiar with the language that has been used. Explain why Albert would be able to understand the program. So this is actually transferable skills question. Transferable skills means that if someone knows one programming language because it knows all the constructs, these programming languages which he knows will also be effective for him if he's doing it in a new one. So he would use his transferable skills to understand the new program. He could recognize basic controller structures, as I said, that like loops, conditions, and declarations and all. So this was another question. Now let's solve another question. So viewers, this is another question from May-June 2018, paper 2-3. This is question number 3. It says a modular program design consists of 4 modules. Module 1 has 3 subtasks. Each subtask is implemented by a single subroutine, either a function or a procedure. The subroutine headings are defined as these. Function module 2, it accepts weight as real, returns Boolean. Procedure module 3 accepts weight as real, customer as a string, purchased as date. And obviously it's a procedure, so it does not return any value, neither it is sharing it with by ref thing. Function module 4 purchase date, it accepts purchase as date, account as integer, and returns integer. State the term given to values passed between the modules. This is called parameters. So now draw a structured chart to represent the program design. Use the letters in the table to label the values passed between the modules. All right, so they have shown variable names, parameter names, and values for what is being returned. So let's make it. So we have module 1. Module 1 Module 1 calls module 2, and transfers purchased. Let me solve it, then I'll explain. All right. So module 1 here has 3 subtasks: module 2, module 3, module 4. Module 2 is a function that accepts weight as real. So weight over here is shown with F. So F is being sent, it is real, and then it returns a Boolean. So Boolean is A, so it returns A. Then it calls procedure module 3. So module 3 accepts weight, which is F here, and then customer, which is string D here, and then procedure 3 accept purchase as date, purchased as E here, and then it returns nothing, obviously, nor it is sharing anything. Function module 4 is called then. This is a sequence. Purchased as date, purchased is E, here we go, and then account as integer, account is C, there we go, and then it returns an integer, which is B. So that is how it will be solved. Let's see what's further. So that's it for this question. Let's solve another question. In our last question, I forgot to put iteration symbol over there. As we know that all these subroutines, search and allocate and enable, are being called inside a while authorize is equal to true loop, we would have to actually put this iteration symbol there as well. So let's solve another question. This is question number 4 from May June 18, P22. Let's solve it. It says that the structure chart shows part of the design of a program for an online shopping system. There is a process basket. It calls discard basket, remove all items with A. And then it calls change item quantity with B, C, and D. And then it calls E, F, and G. Check out pay and dispatch with E, F, and G. Draw on the chart to show the following facts. Each of the module at the lower level, this level, returns a Boolean parameter X. So let's see how. So every module is returning a Boolean variable X. So second, process basket will call only one of the modules shown at the lower level. It means that we have to include this diamond box at this level. So maybe we fill it or something. So this is now done. All right, so further it says that the parameter A to G shown on the chart will be used to pass the following information: payment details, quantity, basket ID, delivery address, and item ID. Now, this question has nothing to do with your knowledge. It is as per your general knowledge. I mean, knowledge of the subject. It is your general knowledge. It is a general knowledge question, maybe. So let's see what could be A. A, discard basket. Process basket calls discard basket. So A should be the basket ID. Then it calls with B, C, and D. So what? Change item quantity. So the B should be basket ID, I believe, and C should be item ID, and D should be quantity. So basket ID, item ID, and then D is quantity. And then it calls check out with pay and dispatch. So E should be basket ID again. What needs to be dispatched, and F should be delivery address. And then payment details remain. That should be G. So this was another easy question. Let's see what's further. So question ended. Let's solve another question. Another question from May June 2018 P21. Question 4. It says that a structure chart is used in modular program design. Iteration and selection are two features of an algorithm that may be shown on a structure chart. Give three other features. So, as we discussed already, there is hierarchy, there are parameters, there are level, there is sequence, selection, interface, iteration, might be so many. So let's hierarchy, parameters, interface between subroutines, sequence, selection, repetition. All right. Now, pseudocode for a function is shown. Function item process, which accepts add item and in string as a string and returns boolean. It has a local variable return flag as boolean. Return flag is false upfront. If add item is equal to yes, so this add item is a string along with in string. Then return flag add to list in string. So it is actually calling other subroutines, but as per the condition. Else call remove from the list in a string. And then it returns return flag. So this would be, the name is item process. Calls add to list and then remove from list. Two subroutines. There is selection involved. So this is in string. If it is true, otherwise it calls with this with in string. And return flag is being assigned, but this add to list is actually a function. So it returns a value which is being caught in return flag over here. So the value which is being returned is being caught in return flag. So that's about it. Let's see what's further. So the question ended. So these are fairly easy questions. Let's solve a few others. All right, this is question number 3 from May June 15, 9608, paper 2-3. Let's solve it. A flooring company provides for each customer an estimated price for a new job. Each job is given a job ID. The job cost is calculated from length nearest to meter and width nearest to meter again of the room. The process for calculating the price is as follows. The floor area is calculated with 18% added to allow for wastage. The job cost is calculated at $50 per square meter. The structure chart shows modular design for a program to produce a new job cost. So produce flooring job cost, then there is customer name going from input job cost, produce flooring job cost module has called subroutine input job data. So give data items corresponding to the labels A to E in a structure chart. Now this is one of the early questions appeared. Actually, structure chart was introduced in 2015 to the syllabus. So it was one of the early questions. So it is sort of open-ended question, whatever that you have got from this question. All they want to see is that if you get what is being asked for. It is again sort of general knowledge question. It has nothing to do with your computer science knowledge, but analytical skills. So let's see. So A should be width, then job ID, then length, then D is again customer name, and then job cost. So as you can see that input is what is the width and height of the room with the job ID, and then it calls calculate job cost. So this, that is where the length, width, and job cost. So length and width is coming from here, and job ID is going from input job data. And then it calls send estimate to the customer, obviously with the customer name and job cost, which was calculated over here with the job ID. So let's see what it further says. The procedure below is one of the modules shown on the structure chart. Parameters can be passed by value or by reference. Complete the procedure header below showing for each parameter, its parameter passing mechanism, its identifier, and its data type. So let's solve it here. Calculate job cost. So procedure, calculate job cost by ref job cost. Since it is not returning, as currency, by val, length as integer, and by val, width as integer as well. All right. So this calculate job cost here is being given length, width, and job cost. Since it is a procedure does not return a value, job cost should be by ref, means job cost, as we as you know that this job cost cannot be returned by procedure, does not return a value. So if If you want something back from the procedure, you have to make it by ref. So it means that job cost was produced over here, and it was shared with it, calculate job cost, and when the job cost was updated, this called subroutine updated job cost, and it was updated over here as well, because the address of the variable is being shared, not the actual variable. See, for that you need to understand that this shows that this arrow shows, data couple shows that something is going back, but over here they are telling that this is a procedure. This is a procedure. So if it is a procedure, then how come it will return? That's the only way that to make it by ref. So let's get back to our pre-release material. We have fairly good knowledge of structure charts now. So let's see. Task 1.1 says that consider how problem is decomposed. Problem is decomposed by splitting it into smaller parts. I discussed for this and its advantages in detail. Task 1.2, design a modular program to implement the activity described in task 1. Produce a structure chart to represent a modular structure of the solution. The chart should address the sequence, any module selection or iteration, the parameters that are being passed between the modules. We have solved so many questions, all it was clear over there. Task 1.3 says that for each module, decide whether the solution should be implemented as a procedure or function. We had a greater discussion for it. Remember that function does not accept any value from the user or from the console. It does not show any value over the screen or the console. This is as per the sense coming from your syllabus. Function always accepts values as parameter and returns a value. Whereas the procedure accepts values as parameters with parameters, and it may output over the console as well as it returns a value. Since the by nature procedure cannot return a value, it always returns a value uh, by ref. For each module, decide whether the solution should be implemented as a procedure or function. Justify your choices. So we had a greater discussion for this. So I consider all these tasks related to structure charts completed now. So let's wait for next video covering task 2, which is algorithm, arrays, and pseudocodes. Until then, take care.